Give the people what they want. Give the people what they want. Tried to remix it. Anyway, gotta get the people. Get the people what they want. And they want to know about solving systems of equations with simple elimination. So that's what we're gonna do. Let's go ahead and get down to it. Yeah. So, you have a system of equations. For example, it says 3x minus y equals 10 and 4x plus y equals 32. And you want to know, what is the solution? In other words, where do those two lines cross? In other words, what is the ordered pair of the point where those two lines cross? Because that represents a solution. Where the two lines cross, what that point is, what is its ordered pair. You're trying to figure that out, but you don't want to graph them. Well, guess what? You have other options. You can use simple elimination. Now notice, the reason I can't solve this problem is because I have two variables in each equation, and I can't solve an equation with two variables in it. So, let's just write this. The reason I cannot solve this now is because each equation has two variables. Both of those equations have an x variable and a y variable. So I can't solve it with two things I don't know. Okay? So, I want to eliminate one of the variables. Alright? So I'm going to eliminate one of those variables. And the way I'm going to do it with simple elimination. So, steps for simple elimination. 1. Find the variables that cancel out. Right here, I'm looking at y. If I add these together, top to bottom, 3 plus 4x equals 7x. Negative 1y plus positive 1y equals 0 y's, which is nothing, which cancel out, right? And 10 plus 32 equals 42. So find the variables that cancel out. In this case, it was y. Second is add the equations together. Right? So I added 3 and 4. I added negative y and y, which canceled out, and I added 10 and 32. And then finally, third thing says solve for your variable. Right? So I'm going to go ahead and solve, in this case, for x. X equals 6. My final step then, well, I hope this is step 4, if I remember correctly. My final step says plug your answer back into the equation to solve for the other variable. Okay? So now that I know x equals 6, I can plug back into either one of these original equations. I'm going to do the 4x plus y equals 32. But I'm going to substitute 6 for x. So 4 times 6 plus y equals 32. This is 24 plus y equals 32. This is y equals 8. So my answer, my solution, is the ordered pair. X is 6 and y is 8. There's my answer. Okay? These take a decent amount of work, so you have to be careful. You don't want to make small mistakes. One messed up negative will mess up your whole problem, and you're doing a lot of work. All right? So we're going to follow these steps and do the next problem. So let's say example 2. Example 2 says 2x plus 5y equals 41. Negative 2x plus 6y equals 14. What variables does it look like it's going to cancel out? Why don't you go ahead and figure that out right now? I'm seeing if I add these together, positive 2 and negative 2 will cancel. 2 plus negative 2 is 0, so those cancel. 5 plus 6 is 11y. 14 plus 41 is 55. I end up with 11y equaling 55. Now I just solve for y. Divide by 11, y equals 5. So far I know y equals 5. What do I do now? I go and plug a 5 back into either one of these equations and solve for x. I'm going to use the top equation. It said 2x plus 5y equals 41. Now I'm going to substitute 5 in place of y. So 2x plus 5 times 5 equals 41. 2x plus 10 equals 41. Minus 10, minus 10, 2x, equals 31, divide by 2, divide by 2, x equals 15.5, 15 and a half. Alright? So what I end up with, y equals 5, I plug 5 in, 2x plus 5y equals 41, 5 times. I knew something didn't look right. 5 times 5 is 25. Hopefully you all caught that. 41 minus 25 minus 25. 2x equals whatever. 41 minus 25, that is a 6, that is a 16. X equals 8. There we go. So my final answer in my ordered pair is the point 8, 5. That's my solution to this equation. See that mistake that I made? Here's the key in all of these. If the numbers don't work out pretty, especially in Khan Academy, you probably did something wrong. Because they set these up so you should get relatively nice, pretty numbers. Okay? Last one we're going to look at. Example 3 says 3x plus 5y equals 20. And 3x plus 2y equals 17. What's going to cancel out here? My hope is that you're looking at this and you're saying nothing is going to cancel out. Because if I add this, 3 plus 3 equals 6. Those don't cancel. 5 plus 2 equals 7. That didn't cancel. And clearly it doesn't matter if this cancels or not. So these don't cancel out. But how could I make these cancel out? What are my other options? Well, instead of adding On this case, I could subtract. Okay? So what I'm going to actually do is I'm going to take this whole equation and multiply it by -1. So I end up with a -3 right here, which is basically like subtracting. Alright? So if I multiply this whole equation by -1, which is legal, this becomes -1 times 3. So this becomes a -3. -1 times 2, this becomes a -2. And -1 times 17, this becomes a -17. Alright? So I just changed the equation. So now, I still have my same first equation, 3x plus 5y equals 20. But my second equation is now -3x minus 2y and a -17. So hopefully you can see, now these cancel out. Now I've made it so the x's cancel out. So I can take this whole thing and multiply it by -1 so that I can make my one of my variables cancel out. So now these cancel, that becomes 0. 5 plus -2 is 3y. 20 plus -17 is 3. Y equals 1. So far I figured out that y equals 1. I go ahead and plug it back into any of my original equations. I'll take 3x plus 5y equals 20. And I'm going to plug this 1 back into it. So 3x plus 5 times 1 equals 20. 3x plus 5 equals 20. Minus 5 minus 5, 3x equals 15. I'm left with x equals 5. So my ordered pair, x is 5, y is 1. Alright, that's what I have for you today. Solving with simple elimination. Be careful on these. Make them happen. Do it big. Out.